Here we utilize this amount formula that is given by A equals P times of 1 plus R over N raised to the power of Nt, where this P represents the principal and this A represents the amount after T years, and N represents the number of times compounded. This is number of times compounded. R represents the rate of interest in decimal. This is in decimal. And T represents the time in units of time. So let's calculate the amount when n equals 1. So in this case, we consider this P equals $3,500. So I just simply utilize this number 3,500. R is the rate of interest. R equals 2.5%. And this we have to convert to decimal. We do this by dividing by 100. So 2.5 over 100. And this equals 0.025. And T here is 30 years. And N equals 1. Since we calculate for the first case, that is N equal to 1. And this means it is compounded one time per unit of time. So let's substitute into the formula. Let me copy the formula, that is A equals P times 1 plus R by N raised to the power of Nt. So the amount will be, plug in P equals 3,500 times 1 plus rate of interest is, we utilize the decimal form, that is 0.025 divided by N is 1 times of raised to the power of 1 times of T is 30 here. So let's simplify and we can plug it into the calculator. So this is 3,500 times this is 0.025 divided by 1 is 0.025, and when we add 1 to it, we get 1.025 raised to the power of 1 times of 30 is 30. So when we plug this into the calculator, we get approximately 7,341.49, and this is in dollars. So this is the amount uh, after 30 years when compounded one time with the principal and the rate of interest given. We now calculate the amount for n equals 2. So everything remains the same except n equal to 2. Let me plug it into the formula. So we get A equals, principal is 3,500 times 1 plus rate of interest is 0.025 divided by n equal to 2, and raised to the power of 2 times of t is 30. So this equals 3,500 times 0.025 divides by 2, we get 0.0125. And then when we add 1 to it, we get 1.0125. So I'm going to put 1.0125, and this raised to the power of 2 times of 30 is 60. Once again, we plug this value into the calculator, and when we do that, we get approximately equal to 7,375.13, and this is in dollars. So this is the amount. In the same way, we plug in n equal to 4 and n equal to 12 as well as n equal to 365 into the same formula to get the amount for the different values of n. That is, basically, we just have to change the value of n. For 4, we have to put this as 4, and this should also, we should put 4, and here also this will be 4, and this will also be 4 when n equal to 4. And similarly, when n equal to 12, we just have to change these two things, to 12 and evaluate the values. This is 12t. This is 0.025 divided by 12 times of 12 times of 30. So likewise, we can calculate for when n equal to 4, 12, and 365. Now let's calculate for continuous compounding. And for this, we use a different formula. That is, the amount is given by p times e raised to the power of rt. Everything remains the same. That is, amount a is the amount after t years, p is the principal, r is the rate of interest in decimal, and t is the time. So let's plug in for this one. When a equal to, that is, we calculate a equals 3500 times e raised to the power of, r is 2.5%, so it is 0.025 in decimals. Time t is 30 years. So we put 30 here. Once again, we plug this value into the calculator. And when we do that, we get 7,409.50. This is rounded to two decimal places. And this is in dollars. And so we have completed the table for different values of n by calculating the amount as well as for continuous compounding.